on the recording, so that way you have access to this later on. Okay, so let's clear this because we're going to need some room. So first of all, for this question, for question 25, which is the Heparin Protocol, the biggest thing is you haven't seen this yet. Because you haven't seen this yet, it gets a little bit frustrating because you're like, what are we supposed to do with this monstrosity here? So first of all, I just want to let you know where it says numbers 1 through 15, that is the Heparin Protocol, meaning it's the standard that is like taped up on the wall or wherever they're doing these, making these calculations and following the recommendations. And if you do a Google search or any other search for Heparin Protocol, you're going to see this format here. So you do not need to answer everything that's listed there. All you need to answer is the ABC listed below the protocol. You don't need to worry about the neurochecks, the GAIAC stool, the CBC count. You don't need to worry about that at all. You just need to know, you just need to be able to calculate the bolus dose and then what you're going to put them on infusion-wise. So it tells us, the protocol says bolus patient with heparin 80 units per kilogram body weight and start a drip at 18 units per kilogram per hour, and the patient's weight is 110 pounds. So the first thing we have to do is we have to convert the patient's weight from pounds to kilograms, and so that would be 50 kilograms. Okay, so all I did was divide by 2.2, just in case you're wondering how I got this magic knowledge. All right, then we go down to A, where A says calculate the number of milliliters to administer for the bolus. It tells us what to do for the bolus in the beginning parts of the protocol and also in step 10 of the protocol, bolus with 80 units per kilogram. So I'm just going to denote this as A. So my patient's weight is 50 times the 80 units per kilogram. We know we've done it right because we can eliminate kilograms, and we will have 4,000 units. Now, if the question said how many units to bolus with, we'd be done, but it doesn't say that. It says how many milliliters to administer. So now we have to go back to the protocol, and if you look at step 2 in the protocol, step 2 in the protocol says heparin, 25,000 units in 250 milliliters, half normal saline. Bolus dosage strength, 1,000 units per milliliter. That's the information you need in order to answer the question. So we're going to do another conversion where we're going to get rid of units to convert to milliliters. And you will have the answer of 4 milliliters. Is anyone not seeing where I'm getting this information from? Okay. So a couple of constants. This is given to you. This is always going to be used for the bolus dose. Okay. This may change. The 80 units per kilogram may change, and I'll show you the example of that in a moment. But the bolus dose, the 1 mil per 1,000 units or 1,000 units per milliliter, that's always going to be the same, and you would always use that conversion when calculating the bolus dose. And since A said to calculate the amount of milliliters for the bolus, we're using the bolus dose information. When we're going to do the next thing, which is the drop rate, then we would use the IV bag for doing that. So let's go ahead and work through that. So B, we have the same patient, same weight, but now we're calculating the drop rate or the flow rate. Now it tells us initially to start a drip at 18 units per kilogram per hour. So that's what I'm going to multiply my 50 this time. 18 units and then kilogram hour. We get rid of kilograms. Okay. And we when we do 50 times 18, we get 900 units per hour. Again, like I stated in A, if they wanted units per hour, we'd be done, but they don't. They want milliliters per hour. So that's why I go back to step 2 of the protocol, where it tells me I have 250 ml of half normal saline, and within that, we have 25,000 units of my heparin. Okay? So this is the thing that I would always use for this for when we're doing the rate, the flow rate. Okay. We know we did this right because we're going to be left with milliliters per hour, and this gives me 9 milliliters per hour. A helpful little aside, this right here is the same thing as 1 over 100. And because the protocol is standard, it will always be that. So if you want to simplify your process, you can certainly use that as your shortcut. Just make sure you don't do 1 over 1,000, because then you're doing a bolus dose strength. So on the test, this would be an example of one question. You would calculate a bolus dose and a flow rate for answering one question, okay? The part C would be a separate question, but I gave you A, B, and C, which C has parts 1 and parts 2, to give you basically 2 questions built into one, but on the actual test, you'll only have either just A and B, or just C parts 1 and parts 2, okay? Now, in C, we've run the initial protocol, and we go and we test, and we run it for 6 hours, and now we're testing their ability to clot. And so we're looking at their APTT. We see that it's an APTT of 43 seconds. So now I go up into the boxed area, 11 through 15, where it gives us the APTTs, and we follow the corresponding information for the box recommended. So 43 seconds falls into the range of 36 to 44 seconds, which is what you see with box 12, or step 12. Step 12 tells us to rebolus with 40 units per kilogram, and then to increase the rate by 2 units per kilogram per hour. So if you're looking at that and you say, okay, well, 40 units is exactly half of what we started with, you did that right, and your answer would be 2 milliliters. But for practice, let's write it out. 50 kilograms, patient's weight, right? Doesn't change. This time, instead of 80 units, it's 40 units per kilogram, which gives me 2,000 units. Since we're still talking about the bolus, I'm going to use the bolus dose information. And then I get 2 milliliters. Okay. So answer A, answer C, part 1, answer B. C, part 2, we're going to do a new flow rate. Now, the new flow rate says to increase by 2 units per kilogram per hour. Now, you have to go back to the original 18 units per kilogram per hour. So we started at 18, we're going to increase by 2. So my new units per kilogram per hour is going to actually be 20 units per kilogram per hour. That's a commonly missed thing, and a lot of times people ask me that question, where did I get that information from? That's where that's coming from. We just add 2 to the initial flow rate based off of the patient's weight. So again, same patient, 50 kilograms, 20 units per kilogram per hour. Which gives me 1,000 units per hour. We eliminate kilograms. And then you can either do the 1 over 100 like I mentioned to you before, or just to keep it consistent, going back to step 2, because we're talking about the flow rate now, we need the IV bag information. And we'll have 10 milliliters per hour. So really the only thing that I can change on this question when I wrote your test and I changed the ways that I asked these questions is really just changing the patient's weight. So you can choose a weight and you can work through this process, and you would basically follow the same flow using the same numbers that I'm boxing. The only thing that would change would be the patient's weight. Okay, that would be the thing that would change, is the patient's weight. So if you had someone that was 210 pounds, then you'd have a different kilogram, but you would still plug in the same numbers. You still initially multiply by 80, and then whatever that number is, divide by 1,000. Then you would multiply by 18, whatever that number is, divide by 100, and you'd get the same answers, or you would follow the same process. So my challenge to you is you can just come up with a different weight and then practice. And if you need confirmation on your answers, just let me know, and I can give you that. You can even email your weight that you started with, and then just to make sure that you get the right answer. One thing I'll say is, when you have the patient's weight in kilograms, round to the nearest tenth. And then when your answers would also get rounded to the 10th. So don't forget to round to the nearest 10th. So like if your answer was 4.64 milliliters, you would change that to 4.6 milliliters. Okay. You're welcome. Any other questions?
Yeah, can I ask a question?
Absolutely.
So when you're saying that the only thing that will change is the weight, you mean because of the way that the question on the test is going to be posed, or like it's always going to be 80 units? Like that's never going to change. The only variable is the weight. Everything else.
Exactly right, because like I said, if you do a Google search for Heparin Protocol, you're going to pull up these steps 1 through 15, and all the numbers are the same.
So it's always 80 units per kilogram. It's always 18 units per kilogram per hour.
For the initial bolus and for starting, yes.
Okay. Thank you.
Yeah, you're welcome. All right, any other questions on the Heparin Protocol before I move on to question 24? Oogie. We'll do that. All right, so question 24. Now, this is actually just, I'm sorry, this is not. 22 and 23 are good practice for answering part B and part C2 of the Heparin Protocol. That's all 22 and 23 is. 22 is exactly following basically the Heparin Protocol, except that you're using 1,000 milliliters instead of 250 milliliters, but it's the same setup. So 24 is, we're going to start our infusion. But first we need to figure out how long it's going to take. So if I have 1,000 milliliters and they're infusing at 50 milliliters per hour, that's going to be 20 hours. Okay, so 20 hours is going to go by. If we start at Monday at 8 a.m., we want to know when it's going to stop. So I always say, if you were to do 24 hours, it would be Tuesday at 8 a.m. If you subtract 4 from that, so minus the 4 hours, minus the 4 hours, Tuesday at 4 a.m. And that's what they're looking for you to do. Of course, you know the real answer to this question is when the alarm goes off, or when the light or the monitor starts flashing, indicating that it's time to change the IV. But they ask you to do these things. So, yep. So the person that asked that question said that was easier than thought, and that's exactly right, because there's really less math involved than what you may have initially gone in thinking it was. All right. Any other questions? Yep, you're welcome. Absolutely, I can go over number 13. So question 13. All right, so we have dexamethasone sodium phosphate, 5 milligrams IM every 12 hours with a patient weighing 127 pounds. The strength of the vial is 4 milligrams per milliliter. Since we don't care about the patient's weight, we don't need to account for it. So all we're going to do is do the 5 milligrams, which was what's ordered. And then I'm going to do this dimensional analysis wise. 4 milligrams per milliliter. And then 5 divided by 4 for number 13 will give me 1.3 milliliters. I imagine that was rounded. I'll double check. Okay, yeah. So the original would have been 1.25 milliliters, but because it's a number greater than 1, we round that to the nearest tenth. When you have a number less than 1, then you can leave it in the hundredths place. So if it was 0.25, you would leave the number as 0.25. Any other questions? You're welcome. All right, for 22. So 22, like I said, is going to be very similar to what we did in the Heparin Protocol. So here's how I do this. So since it's looking for flow rate, milliliters per hour, that's where I start. I just start with whatever rate they give me. And like I said, it's very similar to, I guess you could say, the second step of the Heparin Protocol when we're calculating the flow rate after we've accounted for the patient's weight. We're left with units per hour. And so I'm going to start with that. So for 22, it says I'm infusing at 1,000 units per hour. So that's where I start. You could choose wherever you want to start, but my methodology for that is just because I'm looking for milliliters per hour. I know that I have time down below, and that helps me to just organize. And this is where I always start. If you start differently and get the same answer, you're doing it right. This is just where I choose to start. So I don't want units, right? I want milliliters. So I have 25,000 units of heparin in a 1,000 milliliter IV. And then you just, you do your math and you get 40 milliliters per hour. So all I'm trying to do here is cancel out units. Now, if you're doing desired over have or ordered over have, you can do it that way. Just make sure your units are in the right locations, just in case you like to see it this way, times the 1,000 milliliters. Sorry, that's supposed to be a 1 here. 1,000 milliliters, and you still get the same answer. just going to correct my mistakes here. Looks horrible. There we go. You're welcome, Meg. Yes. If you do a search for, and I'll just type it in here, so give me 1 second. If you do a YouTube search for Dr. Rad, the Rad Tutor, you'll see my picture, and you'll see a bunch of videos that I put together, basically going through a lot of these packet questions. There are some questions that are different. I even did an alternative heparin protocol using a different weight. So it's all there for you. And I'll probably post these reviews also on there, because I can just upload the videos. That'll probably be the easiest way to disseminate these videos or these recordings of these reviews. You're welcome. Again, if you have any questions, just you can type it in the chat. You can unmute if you'd like and just say, can you work out this question? Whatever you prefer.
Would you mind going over number 21 real quick?
Absolutely. All right. So the trick with question 21 is you need to ignore the column that says milliliters diluent added. That is just what you would see on the label, and it's and basically just tells the pharmacist or the pharmacy or the nurse how much water or deionized water to add to the powder to get to the solution or the concentration listed in the right column. So where it says milliliters diluent added, you can write, cross that out. Just ignore that table every single time. And then all you need to do is take the 350,000 units over the strongest concentration, which is the 1 million units. And then times 1 milliliter, and you get 0.35 mil. I usually advise that because you're doing this on a calculator or a basic 10 key calculator, sometimes it's easy to make mistakes. Whichever one has the least number of zeros, count them out. 4, 35 over 100 is easier to plug into your calculator than the 350,000 over 1 million. And again, you would leave it at 0.35 milliliters because it's a number less than 1, and you would round to the nearest hundredth for a number less than 1. If you have any questions, Lilia, just ask. Oh, James is back.
Yeah, I couldn't hear you. My I don't know what was going on.
Oh, I wasn't talking, so that
Okay.
could be. Once I just wait until I get questions, so I didn't have anything else to add after I. Did you see that I answered your question?
I did not because it said you were talking, but I couldn't hear you.
Oh, okay. Can you see my whiteboard?
Yeah.
Okay. So all I said was that you ignore the milliliters diluent added,
Mm-hmm.
and then you take the 350,000 units over the strongest concentration, which is the 1 million units per milliliter. And then you don't round that 0.35 because it's a number less than 1.
Okay.
That's all I said, and then I stopped talking.
Okay. So you always use the strongest one?
If it asks you to do that, that's I put that in because it doesn't usually the questions I've seen for these don't ask specifically which concentration to use, and I don't know what you're supposed to know to tell you like it's, but that's why I added to use the strongest concentration. I do believe that that's what you would use, but I'm not 100% on that.
Okay.